In our research group at MIT, we focused initially on trying to put different semiconductors together, and it sounds like a simple process. Well, it's just deposit one material on another. It turns out that we could see that the future really lied in the ability to have semiconductors put together that have different lattice constant. And that's significant because throughout history, if you deposit one semiconductor on another that has a big difference in crystal structure or size, then there's so many defects that form that the material is useless. And so we looked out there and saw that there was a lot of different applications that could be solved, a lot of applications could be addressed by solving this problem. And so, like we were saying, it's one of those good beginning innovation processes to work on, because if you could get by this bottleneck of how to put these films together and not have defects, there's a plethora of applications that could result. The first one of those applications was the strained silicon, which I mentioned before is in your laptops, but that same type of research and innovation allowed us to build a new kind of solar cell. And that's significant because in order to capture different parts of the spectrum from the sun, you want to have different band gaps of semiconductors, and nature has it where they don't always have the same lattice constant. So again, that same fundamental problem of how do I put these films together so I can capture different wavelengths of light so that the solar cell can have even higher efficiency. So for example, we have been able to develop the materials that can go into that, and now we've spun out a company to create those solar cells and get them to the marketplace. To give you an idea of the potential, normal solar cells now, the highest end for low-cost solar cells are between, say, 20 and 25% efficiency. And at the highest efficiency, and say in the 30s and say 35% efficient cells, the cost of those cells is 100 times the cost of the lower cost, say 20% cells. So you could see that there's an opportunity there that because we could put these thin films down on the lower cost substrate, we could in principle make even higher efficiency at the lower cost. And to give you an idea, if you look at these semiconductor films we could deposit, the efficiency should be able to reach 50% efficiency. And so 50% efficiency at the cost of today's low-end solar cells would be a really big impact on solar energy. And we suspect that it won't develop, of course, immediately. We talk quite a bit in our innovation model about how long it takes these fundamental technologies to reach the marketplace. We've already put in many years of research, and now in the startup company we're starting to commercialize that. And of course, to grow volume there will take years because you have to first sell at a low volume and get higher margin. That's why we chose to sell into markets like satellites and space systems and new potential solar aircraft first, because that's where we can get margin, ramp up the volume. Because all these technologies, if they don't go to higher volume, they'll never be low cost at the end of the day. So we have to go into those markets first and drive the technology to the point where then we can have it on our rooftops. So the reason that this problem wasn't solved is that the research, first of all, that goes into this is the kind of research that the large corporate labs would have done many years ago. But in a competitive environment, the timelines are too long. So if you look at a single organization investing that far out, the return isn't high enough for them. And so they need to leave that to the outside world. And in our case, we had been developing that kind of research for strained silicon technology. Now we could apply it to solar. And so our timelines are much longer. We're at a university, and so we're getting investment from the government to do that kind of research, which hopefully, like we've been doing, are spun out into the company and then hopefully bring it to the marketplace and increase volume.